Alright, in this video, we're going to look at some questions from Unit 4, which is numbers 19 through 22 on the final exam review. So here on 18, we're asked to use a discriminant, which we give you the formula for the discriminant, to determine whether the equation has two real solutions, one real solution, or two complex solutions. Now, a couple of things that we need to recall here is that the discriminant is located in the quadratic formula. And the quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So you can see this discriminant is right here. Okay, so it's underneath the square root. Now if you take the square root of a positive number, you get a real number. If you take the square root of a negative number, you get a complex number, also known as an imaginary number. Okay. And then because there's a plus or minus here, if you had plus or minus here or plus or minus here, you're going to have two answers there. You're going to have two answers for this or two answers for that. Or if it's the square root of 0, we know the square root of 0 equals 0, and plus or minus 0 just gets you one solution. So if you're taking the square root of a positive number, you're going to have two real numbers. Take the square root of a negative number, you're going to have two complex numbers. And if you take the square root of 0, you're going to have a real answer because 0 is a real number. Okay? So here on your equation, you need to make sure this is in standard form. Ax squared plus bx plus c equals 0. So here's your a, your b, your c. So in this case, b is negative 5. So this is negative 5 squared minus 4 times a is 2. Oh my goodness, 2. And then c is 1. So negative 5 squared is 25 minus 4 times 2 times 1 is 8. So 25 minus 8 is 17. So since 17 is positive, we have two real solutions. Okay? Two real solutions. Now, how many solutions does it have? If here b squared minus 4ac is greater than 0, that means it's positive. Well, if it's positive, there are two real solutions. If this is equal to 0, since it's equal to 0, there would be one real solution. Again, that's because the square root of 0 is 0. That's a real number, and adding 0 and subtracting 0 gets you the same answer. And then here, if this is negative, if it's less than 0, it's negative. So that would be two complex or imaginary. Okay. Okay. And this is an I, imaginary. Okay. So that's a discriminant. Now, in the next question, they ask us to solve. So, number 20, we're asked to solve. So the first way we should try to solve is by factoring if possible. So let's see if this thing factors. Okay. So here, first term times first term gets you first term, so that would be an x and an x. Last term times the last term's got to get you 35. So we're looking for factors of 35 that can get us 12. Well, that's 135. 2 doesn't work. 3 doesn't go in. 4 doesn't go in. 5 times 7. Well, 1 and 35 can't get you 12, but 5 and 7 can. So this is 5, this is 7. Since the signs are both plus, these are both plus. So this is equal to 0. And then recall from the zero product property that each one of these could be equal to 0. because if two numbers multiply together to get you 0, then one of these two has to be equal to 0. So if x plus 5 equals 0, then x would have to equal negative 5. And over here, x, when you subtract 7, would have to equal negative 7. So your two solutions are x equals negative 5 and x equals negative 7. Now on this one, if we try to solve by factoring, we would have to have a 2x and an x. Okay? Factors of 1 would have to be 1 and 1. Signs, in order to get a positive but a negative in the middle, they'd have to both be negative. So that would have to be your factors. But if we check our outers, you get negative 2x. If you check your inners, you get negative 1x, which does not get you negative 5x. So this doesn't factor. So we could complete the square. That would be ugly here because we'd have to divide through by 2, which is going to create a whole bunch of fractions. So why don't we just use the quadratic formula? So x equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. And again, this is going to be your a, your b, and your c. So x equals opposite of b, so b is negative 5, so that's going to turn into a positive 5, plus or minus the square root, b squared, so this is negative 5 squared, minus 4 times a is 2, times c is 1, all over 2 times a, and a is 2. So x equals 5 plus or minus the square root. Negative 5 squared is 25, minus 4 times 2 times 1, that's 8, over 2 times 2, which is 4. So x equals 5 plus or minus square root of 17 over 4. And square root of 17 doesn't reduce, so there's nothing else you can do. There's your final answer. Okay. On the last one on this page, here we want to solve, but it's not set equal to 0 yet, so first thing we should do is try to set it equal to 0. So we're going to I would bring both these terms over to this side, leave the x squared positive. So this is going to be plus 4x and a minus 1. Now because this is just an x squared, we would need factors of 1 to get us 4, and the only factors of 1 are going to be 1 times 1, so this does not factor. So it looks like we have to do the quadratic formula again. So in this case, x equals, this is 1 here, so that's your a, here's your b, there's your c. So opposite of b in this case is negative 4, plus or minus the square root of 4 squared minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 1. So x equals negative 4 plus or minus the square root. 4 squared is 16. Negative 4 times 1 is negative 4 times negative 1 is positive 4 over 2 times 1, which is 2. So then x equals negative 4 plus or minus the square root of 20 over 2. Now the square root of 20 has a perfect square of 4. That's 4 times 5. So that's equal to negative 4 plus or minus square root of 4 is 2 square root of 5 over 2. But then 4, 2, and 2 all have a common factor of 2. So we can take a 2 out of all of those. So your final answer is negative 2 plus or minus, that's going to turn into a 1 square root of 5, or just square root of 5, over 2 times 2 into 2 is 1. So we can put it over 1, or that's just your final answer. Okay? So that is solving quadratics.